So this problem you're asked to write out a nested for loop in longhand and to also compute the value of z after it has executed. So what I'll do is copy this, and on the Mac it's Command C, and then Alt Tab over to my RDP desktop. And then this is a Windows machine, so to paste I need to do Control V, or I could do Edit Paste. And so this is the program that I want to write a longhand version for. And you'll notice that MATLAB has these little icons here that allow you to expand and collapse different parts of text. And what's happened is that it's recognized this block of a for loop and said, well, maybe you don't want to look at that, you just want to look at this, and then this is your do something part, and you're not really interested in it. And you can expand and contract the code to look at selected pieces. Okay, so just like a regular for loop, this for loop connected by this for and this and has something inside of it, and this something inside of it, according to the rules of for loops, is going to be repeated 3 times. Each time the value of this index variable I, which always appears after the for statement, is going to be set to the values of 1, 2, and 3. And so I'll do that. I'm going to write an equivalent program above here. Clear, z is equal to 1, that part can't be put in a for loop. And now I have I is equal to 1, and then I'm going to have stuff. I is equal to 2, I is equal to 3. And again, according to the rules of the for loop, I just repeat everything inside there 3 times. So I'm just going to copy and paste this. Copy and paste, copy and paste. And so now this program is equivalent to this program. These two are the same. And I can show that by printing out the value of z at the very end of both programs. And then I'll copy this and paste this into the MATLAB command line. Just here. Paste. It says z is equal to 37. Go over here, clear everything, and then run it this way. And I should get z is equal to 37. And I do. Now the final step is to expand out this for loop using the rules that we've done before. And this is how it goes. I'll do it on top here again. Set j is equal to 1, leave some space, j is equal to 2, some space, j is equal to 3. Now the repeated part is here. And I'll just put that in here. 1, 2, 3 times, and then get rid of this. Now this part is exactly the same as this, so I'll replace it and replace it. Verify that I did it right. Sometimes it's useful to type CLC, which means clear the console or clear the command window. This is the command window. If you ever can't find the command window, which has this command line prompt, you should look into here, desktop, and then select command window. Sometimes it disappears. So for example, if you accidentally click this, you'll say, where's my command window? I have a command history, I have this, and then I have a workspace. And to find it, you just go to desktop, command window, and then it'll reappear. And I'll expand it. So CLC will clear that console so I don't have to see the stuff that I've done before. I'll execute this, copied and pasted, now I'll hit enter. It tells me z is equal to 37. And with these programs, you won't always have the luxury of having MATLAB to evaluate and check things. And so I'll just review how you do the computation yourself. This assigns a value of 1 to z, a value of 1 to I, a value of 1 to j. And this says take the previous value of z, previous value of I, plus previous value of j, and assign that to z. So previous of z was 1 plus 1 plus 1. If I want, I can verify the answer by just doing this. Copy this, and notice I've taken off the semicolon here, so it's going to print out the value. CLC to clear the console does this, and says z is equal to 3. What I've shown you is a good way to do so-called debugging, which is when you find an error or you get a problem in your program and it's doing something that you don't expect, typically you need to go line by line and inspect the value at different places to figure out where the computation went wrong. And so in this case, it's very easy, if you do this mentally, to make an arithmetic error. And if you want to figure out where your arithmetic error is, you just do it like this. So last value of z was 3. So this, I'll just type is equal to 3. And remember that everything after this percent sign, and including the percent sign, is ignored by MATLAB. And now it says, take the last value assigned to z, which was 3, add the last value assigned to I, which was 1, and the last value assigned to j, which was 2, and add those together. So 3 plus 1 plus 2. So I should get 6. And again, I can verify that, clear everything out, copy this, and paste. There we go. Z is equal to 3 and 6. And so this is a way of checking your program and checking your answer. You'll need to be able to do the steps that I just showed you line by line on paper and also using MATLAB. And the reason that you need to do it is that when you write a program, you'll need to figure out what the MATLAB is doing, how it's interpreting your program. As you get to more complex programs, you'll find that it's a necessary step. Sometimes you'll be telling MATLAB to do something and it's doing the right thing, but it's not what you thought you told it to do. And this process of breaking down the for loops and doing the computation step by step enables you to figure out where the miscommunication went between you, what you had in your head, and what MATLAB thought you told it, or what you actually told MATLAB to do. Now in this next part, I've asked that suppose in this program you've used for and then you set the index variable to be I instead of j. And if you did that, then you have to get rid of the reference to j here because j was never defined. There's no discussion or there's no assignment of j anywhere in the program above where this line appears. And so if we change this to I and didn't change this or remove it, when you tried to evaluate this statement, you would say j is not defined and it would be an error. And so this is the program. I've just replaced the j with the I, and I've removed the j down here. And the question is what's the value of z after it's executed? First, let me tell you that you don't want to do this. You don't want to use an index variable twice in general. So here we have 4i and here we have 4i. And as we'll see, if you do that, it does something that's kind of silly and not very useful in most cases. The reason I'm having you do this is because quite often students will choose to reuse this index variable. They get into the habit of seeing 4i equals something, and they assume that the index variable is always going to be named I. And the fact is, it doesn't have to be named I. It can be any valid name. It could be capital P. It could be the name BOB. Any valid syntax for a variable name. So let's take a look at what's going to happen with this program, and I'll go back to my editor and I'll say, well, this program is very much like the previous program, so all I have to do is make some modifications to this. everywhere that I had an I, everywhere that I had a J, replace it with an I. So I'll do that here. I, I. And then I want to get rid of these J's. If you want a fast way of getting rid of something, copy this text and then choose Edit, Find and Replace, and it says find this text and replace it with, in this case I'm going to replace it with nothing. I'll replace all, and there, it's magically removed all of the plus J's. So what I have here now is a situation where I've defined I, and then I've assigned a value to I, and then I've assigned a value to I again. And so this is kind of silly. There's no reason for this to be here and this to be here. And then here I'm saying I is equal to 1, doing this, I is equal to 2, doing this, and so on. And down here I say I is equal to 2, and then right after that I change the value of I. All right. This is how you would evaluate this program to figure out what's going on. And as a general rule, anytime you see a value assigned to a variable, and then on the very next line it's assigned again to a different number, as a general rule, anytime you see a value assigned to a variable, we've assigned the value 2 to a variable named I, anytime you see that and then immediately after or shortly after you see it changed, so here I've changed it from 2 to 1, it's, as a general rule, you don't want to do that. It's probably a mistake in your program or your thought process. And this is just an example of where it comes up.